love to teach you guys R, but it's R. It's a pirate language. I'm kidding. But it's a programming language, so it's tricky. I don't want to teach you guys how to program because you probably don't want to learn how to program. So Brian, what'd you get?
I got it's 0.90345024.
So, question. I just want to share this before we move on. In the project, if you went through the last little bit with the rectangles, at some point in there I said, don't worry if you get a repeated number. So if you used a random number generator to generate 5 numbers, you may have gotten the same number twice. And I put a little throw out there, oh, by the way, you're probably getting about 10% of the time anyway. It's something you may have stopped and go, now how the hell did he know that? How did he know 10%? The answer was, I didn't. I calculated it. I didn't know it. I kind of thought there'd be a good chance of a repeat. I just didn't know how good. So I calculated it. So Brian asked, how did you know? So what I did was over here, during the break, I said, let's calculate the chance of getting a repeat by instead calculating the chance of not getting a repeat, which is easier.
I tried that and
That's okay. It's a 243. It's a bastard move from 243.
Well, I had the process. I
You
just
did.
was not getting the right
It's
answer,
okay.
so.
It's okay. Don't you worry. So here's the process. So the idea is, if you selected 5 numbers at random, from 1 to 100, what's the chance they're all different? This is the birthday problem. If you remember the birthday problem from 243, it's that problem again, sort of. So the first thing I said, Brian, think of a number. He said 17. And I said, well, if you only pick one number, there's a 100% chance it's going to be unique because you picked one number. Hopefully that's believable. What if you pick 2 numbers? Well, he picked 23 next. And I said, what's the chance you pick a number that's not the same as the first? Well, hopefully, it's 99 out of 100. Hopefully you can believe that, right? 99 out of 100. Hopefully. How about you pick a third number different from both of the original 2, then it's 98 out of 100. It's always out of 100 because you're always going back in to pick from the original 100. Chris, go.
No,
No, fair so far.
well, I was thinking it would be 101 numbers because you count 100.
I don't think I had a 0.
Yeah,
I think I started at 1, so it's going to be good for you, though. Good for you for not forgetting 0, because that's important sometimes, actually, quite often. I think of that whenever I ride my bike down, hang on, Eastview, right before it hits Sierra. There's
Oh yeah, that's right.
20 to 30, the sheds, number 20 to 30. I'm like, there's 11 sheds in there, there's 11 sheds in there. My poor robotic brain remembers that every time I ride down a turn right. Anyway, and you keep going. How many numbers you pick? You're picking 5 numbers, so you drop down 5. You multiply this out, and Brian just told me that adds up, that multiplies out to 90%. Which means there's a 90% chance you won't get any repeated values, which means there's a 10% chance you will, somewhere. You might get the same number 5 times, which time you lay down and take a nap, because that's pretty awesome that would happen.
But that's only if you're using a random number generator. If
Absolutely!
you do it by yourself, you're going to obviously not pick the same numbers.
It's probably closer to 0 if you do it by yourself, because your brain won't let, but then your brain's not being random, right? What's more randomish?
It is
What's
random.
more randomish?
It's random in the fact that you're picking different numbers.
But it's not random in the fact that you're ignoring the possibility of clumping. Your human brain, if I ask, I've never tried this, I should try this too, I'm coming up with good ideas today. I should ask my 243 kids on the first day, write down 5 numbers from 1 to 100, and see if anybody writes the same number twice. You know what I'm saying? I guarantee they won't, just like you said, Chris, because your human brain won't let you do that, but that's the opposite of randomness. Randomness says every number has the same chance of being picked every single time. But what you're saying is if I pick 17, I will not pick 17 again. Well, that's not random anymore. 17 should have just as much of a chance as 27 or 37 or 47 or 1 or 100 or anything else. But it's hard for us to process that as humans because we suck at being random. It's a good point. It's a good point. I'm not saying it's a bad point. I'm saying it's not random. Please understand the difference.
But if you say, then you could, well, okay. But
No, I love what you're saying.
You'd have to say, pick 5 numbers from 1 to 100, and you can pick the same number if you want.
But then I've changed the behavior of your brain, I guarantee.
Well, that's true.
I see, that's what I don't want to do. I want to test your brain's behavior, how random it can be without, yeah. If there was a way I could do it, if there was a way I could phrase it without saying, and you could also pick, like if I could use the word inclusive or with repetition or something along those lines that wasn't so vague as, go ahead and pick it more than once if you want. Like if I could be less obvious, you know what I'm saying? If I could be less obvious. I think it's a great experiment to do. I can't do it on you guys because I just ruined you by talking about it, but that'd be fun to do, wouldn't it? Yeah. So anyway, Brian, great question. Wanted to make sure you got an answer if you wanted it. Fair enough? Yeah. It's good. Chris, I love what you're saying, man. I'm not trying to doubt what you're saying at all. I think it's great.